Hello students. Today let us study finding the maximum and the minimum. That is the max min algorithm. Okay. So how we are going to find out the max min algorithm? So in the textbook they are given first the straight max min. So you know to write a simple program to write a simple algorithm how to find the max and the minimum element. So you can see here. You can see here how to find the max and so let me take max is equal to and min is equal to a of 1. Then from the next element, if at all a of I is greater than max, then max is equal to a of I, and one more if loop a of I is less than a min, then min is equal to. So this will find out which is the maximum element and which is the minimum element. Okay, and this is a straightforward max and min problem. But this takes a longer time to find out which is the maximum element and which is the minimum element. You can see here there are two comparisons which will take, it may take n square or n cube to find out which is the maximum element and which is the minimum element. So instead we can go with the divide and conquer method where it takes where the time complexity of the particular algorithm is comparatively very less when compared to the straightforward max and min algorithm. So here how the algorithm has to be solved. I'm using this algorithm. How can we solve the problem? So I'll show you the same problem I've taken over here. Okay, so the index has been started from 1 to n. Okay, it has been started from 1 to n. These are the elements which is being given. So I have written the indexes here. So now starting from the root node. When I start from the root node, my lower index. So 1 indicates my lower index. Okay, that is the first index. And 9 is the last index. Okay, 9 is the last index. So I have kept these two the values as empty. This first element will give me the max element and this one will give me the min element. Okay, so how to find? So initially I don't know what is the mix, which is the max and which is the min. So I have from 1 to 9. Right, no, my index. So what I'll do first, divide and conquer. As the name says, I have to divide my given array. So I will be doing my division into 2. Okay, so it is 1 plus 9 by 2. We get 10. 10 by 2 is 5. So 1 to 5 will come to the left hand side of the tree and from 6 to 9 will go to the second part of the tree. So now I have 1 to 5. So that means from 1 to 5, these elements will fall into the left hand side of the tree and from 6 to 9 it falls onto the right hand side of the tree. So again there are more elements, so I don't know what is the maximum element and what is the minimum element even here. Then again what I have to do, I have to again subdivide this particular array. Now I got a sub array here, so again I'm going to subdivide again. So 1 plus 5 is 6, 6 by 2 is 3, so 1 2 3 will go to the left side of the sub array and from 4 to 5 will go on to the right hand side of the subarray. In the same way the other side also. So when it comes here again 1 2 3, right? No, 1 2 again I have to subdivide it. That means it is 1 plus 3 is 4, 4 by 2 is 2. So 1 by 1 comma 2 will come here and 3 will come here. So now when I come to the bottom of the tree, you can see here 1 and 2. That means 1 and only 2 elements are there. So from this, I can find out which is the minimum element and which is the maximum element. Always the first one will indicate the max and this one will indicate the min. Okay, so 1 and 2. So in this, it is very easy to find out which is the maximum element and which is the minimum element. So here, that 22 is the maximum element and 13 is the minimum element. If I go on to the right of this right hand side of this subtree, you can see I have only one element 3. Right? No, that means 3 is the lower index and 3 itself is the upper index also. That means only 3. So I have only minus 5. So maximum element is also minus 5. Min is also minus 5. Now when I come to the upper of the, that means divide and conquer always tells that you first go top down and then you go bottom up. Okay, so you compare it. So now I'll compare with the max element of these two. These are the two children's. So the parent will get the values from the children. So 22 and minus 5, which is the maximum element? 22. So 22, I'll write it here. Okay, so 22. So next is 13 and minus 5. 13 and minus 5, which is the minimum element? Minus 5. Okay. Now in this, if I take 4 and 5. 4 and 5. So which is the minimum and which is the maximum? So 15 is maximum and minus 8 is minimum. I'll come on to the other side. 6 and 7. 60 is the maximum element and 17 is the minimum element. If I come here, 47 is the maximum element and 31 is the minimum element. Okay, so 31 is the minimum element. Now, again I'll go to the upper. That means it's bottom up approach, I have to go up. So again, compare the max element. 22 and 15, which is maximum? 22. Then compare minus 5 and minus 8, which is minimum? Minus 8. Now if I compare with this, 60 and 47, which is the maximum element? 60. And then 17 and 31, which is the minimum element? 17. Now again I have to reach to the root node. So 22 and 60, which is the maximum element? 60. And minus 8 and 17, which is the minimum element? Minus 8. I think so the same values what we got here, right? The same thing. So with this, we have an algorithm here which is being explained in the next page. Okay. This is being explained here in the next page. You can see how it is being done. So there are, if at all, if I is equal to j, that is max is equal to mean. I think so we have already seen one case here. In this case, we have seen max is equal to mean. That means the same element will be our max and the same element will be our mean also. So max and max equal to mean is equal to a of I. Else, if I is equal to j minus 1, that means if we have only 2 elements, that means it is in this case. If I have only 2 elements, right now, only 2 elements, then if I have one, then I'll compare a of I, whether a of I is less than a of j. Yes, that means max is equal to a of j and min is equal to a of I. Else, it will go on to the other side, right? Else max equal to a of I, min is equal to a of j. It is very easy to compare. Else, that means if I have more than elements, that means something like this. If I go to the upper bound, right now, then in the case something like this, if I go 1 to 5, then what I have to do? First I have to divide it, right now. Divide the P into sub-problems, correct? P is not small, that means I have more than 2 elements, that means P is not small. So divide the P into sub-problems, find where to split the set. How you have splitted it? I plus j by 2. Then I'm setting max 1 and min 1, then solve the sub-problems. Again I'm calling the max min algorithm here and then again combining and finally I'll get into the further the smallest. I'll reach to the root node by calling this and then I will find which is the maximum element and which is the minimum element. Okay, so advantages and disadvantages. I think so it is easy, you can understand it, you read it, you can go through. So I have already uploaded these notes in your Google Classroom. So just go through this, it is easy and you can find out any doubts, you can clarify it with me in the next class, in the afternoon class. Thank you.